All right, happy Monday. Welcome back. So let's start off with a couple announcements as usual. So homework 1 is posted. It's due this Friday. So remember, like 11:59 was the target time for that. I want to clarify the sort of late policy. So the assignment will be accepted late, but there's a penalty. So if you submit it at midnight, it's 1 point off out of 20. And every hour after that, an additional point off. So you can submit it late if something comes up. You can still get most of your credit. But if you're submitting it like more than about a day afterwards, it's no credit and it's not accepted. So try to get it in on time. Somebody pointed out that the header on the current homework says ME564, not 364. So the header's wrong. The assignment is for this class. I was just using the template from last semester, so sorry about that. But yeah, everything else should be fine. If you do see something on the homework that's like confusing or there's like a typo or something like that, especially if it relates to the actual content, please ask me about it. I do try to make new homework for every class, so there is a reasonable chance that there will be typos. I try to avoid that, but if you see anything, just ask. It's totally fine. Okay. For office hours, I just wanted to take a quick poll by hands. So remember, office hours are scheduled for Wednesday 12 to 1, Thursday 1 to 2. Do those office hours not work? Like, if those office hours don't work for you at all, just raise your hand. Okay. So to those raising your hand, I'm not seeing enough where I think I'm going to change it. I think for most people it works. So what we'll do is let's keep the office hours as they are. If those who raise their hand, if you can't meet with me, try meeting with your TA. You can also email me and we can set something up if it's important. Well, okay, let's stick with the current office hours for now. In terms of where we're going to meet, I said I'd give you a room. I haven't found anything yet, so we'll just meet in my office on Wednesdays and then on Zoom on Thursdays. So my office, again, is 13th floor of Engineering Research Building. Up the elevators, straight to the left on the first door. So we'll just meet there. Lecture recordings are made available. So I should have uploaded the first lecture recording to YouTube. I have a channel, and there's a link to that. So you should be able to find it there. I cut down a few things, like if there's announcements and stuff, I'll try to cut those out, usually. But they're posted there and broken up into chunks so you can kind of track which part of the lecture you want to look at. So the Canvas homepage has the link to that. You can find them there. Solutions for discussion problems. Somebody asked about that. Yes, I will post that. I posted the first discussion solution a couple hours ago. So just look in the files folder on Canvas, and it should be there. Okay. Any other questions or anything before we get started? Yeah?
Will you normally post discussion? Sorry. Will you normally post discussion solutions the lecture after discussion?
Yeah, so the question was, when will I normally post discussion solutions? So I will normally wait probably at least a day to post. I mean, this time it was a little longer, but I want to give people a chance in case they do happen to submit late for a penalty to still get maybe some points. So probably at least a day. Normally it'd be like discussion Tuesday, I'd post it Thursday, discussion Thursday, maybe post it by Monday. For homeworks, I will post the solutions for those as well. That's probably 2 or 3 days after the due date, depending on how complete the solution is at that moment in time. Any other questions? Okay. So I just wanted to pick up where we left off last time. So we were talking about radiation. I got through most of this, but I want to just clean up a couple things because I didn't quite get to all the definitions. So for radiation, remember we're talking about rate equations, things that relate the temperature of the system to heat transfer in the system. So the radiation rate equation here is Q dot radiation is equal to sigma epsilon surface area times this temperature difference, where the temperatures are to the 4th power. So a few things I didn't quite define clearly. So the first thing is the surface area. So we're talking about two surfaces here. So let's call this the surface down here, surface A. Let's call this surface B. So for now, we'll get to more complicated situations later. But for now, what we're going to think about is if it's an emitting surface, it's from surface A, right? So this would be like, we could say TSA here or something like that. Surface A, and it's emitting to its surroundings. So think, I mean, the most logical or easiest example is like me, right? I'm standing here and I'm emitting to the surroundings. What is the surroundings? Well, the surroundings is composed of a bunch of things. You all, right? The projector, everything, right? All those things have slightly different temperatures. For this rate equation, we're just saying T infinity is kind of some aggregate average temperature, all right? So in this case, it's maybe a little bit above the air temperature just because there's a bunch of you in here, but it is kind of the aggregate average. All right, so we're talking about surface area, so AS, right? Surface area is the emitting surface, AS, and then the surroundings is sort of implied as this basically infinite, right? So this infinite area of the surroundings. TS, right? TS is this thing down here, TS, right? TSA, and then, I guess it would be this surface that it can see under here. This is T infinity. All right, so this drawing's not great, but you get the idea that there's an emitting surface. The emitting surface sees other things and exchanges radiation with other things. The other things in this case is this like effectively infinite surroundings area, okay? When we talk about emissivity, we're talking about the emissivity of surface A, okay? So this is the rate equation for radiation. Okay. Any questions on this or the convection or conduction rate equations before we move on? Okay. So this kind of covers the introduction to rate equation part. So now what we're going to do is we're actually going to go into 1D steady state conduction. So the goal that I have for this lecture today is for you to kind of understand the process that it takes to go through and analyze some conduction problem and come up with a temperature relationship that relates temperature to heat transfer. Okay, so recap, last time we talked about 3 modes of heat transfer. We talked about conduction. Rate equation for conduction is Fourier's law. You can formulate it in terms of a specific heat flux, right, this Q dot double prime, or in terms of just plain old Q dot, which is dimensioned watts. And that's conductivity times some rate of temperature with respect to a position coordinate. Convection rate equation is Newton's law of cooling. That's a heat transfer coefficient times surface area times the temperature difference. Radiation, and we just talked about. Okay, so that's our quick summary of last time if you're taking notes on what was important.